All right, so this would be the limiting reagent problem. Limiting reagent's really easy. I've already done the work here for you. Basically, imagine if I tell you here is a reaction. I've got two hydrogens reacting with oxygen, making two waters. If I had 9 grams of hydrogen and 23 grams of oxygen, how much water would get made? So if I have two different reactants about here, one is going to run out before the other one will. So that's what we're going to call the limiting reactant. How we're going to do that's really easy. We're going to set up our dimensional analysis table here. So 9 grams of hydrogen is what I start with. I'm going to change that to moles of hydrogen. So 1 mole of hydrogen is going to weigh 2 grams of hydrogen. That's from the periodic table. I come over here, 2 moles of water for every 2 moles of hydrogen. So I'm converting my moles of hydrogen to how many moles of water I have. This is the communication of this reaction up here. And then I'm going to convert that to grams of water. 1 mole of water weighs 18 grams of water. Now we're going to do the math there in a sec. Down here, 23 grams of oxygen. That's what I started with here. We're going to pretend we have more than enough hydrogen. We're not going to worry about that 9 anymore. 1 mole of oxygen weighs 32 grams. That's going to give me moles of oxygen. We're going to come over here, 2 moles of water for every 1 mole of oxygen. And then 1 mole of water weighs 18 grams. Now, when we do that math, and I'm just going to do it really rough, this weighs about 80 grams. You'll get like 80 grams of water. When you do that math, it's around 80 grams. So you'll get 80 grams of water made from 9 grams of hydrogen. For 23 grams of oxygen, you end up with only like 25.7 or something like that grams of water. So in the hydrogen, theoretically, from 9 grams of hydrogen, if you had more than enough oxygen, you'd create 80 grams of water. Theoretically, from the 23 grams of oxygen with more than enough hydrogen, you create only 25.7 grams of water. Well, the one you can actually create is this one. You can't create that one. And so what you end up saying is you say, oh, my 23 grams of oxygen must be my limiting reagent. That must be my limiting reactant. That's the one that's going to run out first. So then now what I have is that 9 grams of hydrogen is what's in excess. That's what's in excess. I've got too much hydrogen. Some of it's going to get used up, but not all of it. So then the next question that comes along is, oh, since we know that this is the limiting reactant and this is the excess reactant, how much excess reactant remains? Well, all I'm going to do now is take my 23 grams of oxygen and I'm going to solve for grams of hydrogen that got used up. So 23 grams of oxygen, change it to moles of oxygen, change it to moles of hydrogen, draw my lines, bring my grams of oxygen down. 1 mole is 32. I see that there's a 1-to-2 ratio. 1-to-2 ratio of moles of hydrogen to oxygen. And then we come over here and we're going to bring moles of hydrogen down here. 1 mole weighs 2 grams. So now what we can do is we can multiply 23 times 2 times 2. We'll get a number. Divide it by 32. That's going to give us a number. What that number is going to be is some number less than 9. Some number less than 9. Because this is the amount that got used up. Well, you subtract that number from 9, that's the amount that's left over.